Hello and welcome to Mellow Labs. Today's episode begins a little bit differently to my usual episodes because I have managed to screw up before even properly getting started on the project. See, I was in the investigative part of the project where I figure out if what is in my head is actually feasible. In this case, turning my Bjorn in-ear temperature sensor into a smart one that can send the readings over to Home Assistant. And in the process of disassembling this unit, I have managed to rip the actual temperature sensor off of the flexible PCB that it was on. Fuck. And then rip the flexible PCB in half. I have tried fixing it by just soldering a whole bunch of tiny wires to the sensor and to the board itself, but that didn't work, and also they don't sell replacements, so I am now stuck with a temperature sensor that no longer functions. So on today's episode of Mellow Labs, I'm making my own in-ear temperature sensor, well, smart in-ear temperature sensor, and I don't have a plan yet, but I will right after this message from today's sponsor. JLCPCB has exactly what you're looking for, whether you're a beginner trying to make your very first PCB or a professional looking for more advanced options. JLCPCB has you covered. Need a simple board just to bring an idea to life? They can do that. Need something a little more serious, like a transparent flexible PCB with aluminum backing and V-ring pad for space saving and an ENIG finish? Well, JLCPCB can handle that too. Getting started is super easy. Just click and drag your Gerber files into jlcpcb.com, select what options you'd like to use, and you get an instant quote. Now I know all of that might sound really expensive, but it really isn't. Because of JLCPCB's large scale, they can bring the savings down to you, and they pretty much always have some kind of deals or coupons going on. Like right now, you can get $30 off of a 6-layer PCB, which brings the starting price down to just $2. And if you're a new user and you click the link in my description, you can get $123 in new user coupons, which makes your first few routing mistakes a lot less painful. JLCPCB does everything in-house with strict quality control at every step, and you can see that progress in your dashboard as you're waiting for your order. And for more complex boards, they'll even x-ray them and send you the images so you can see that everything is placed correctly as it should be. Check out the links in my description, and when you think PCB, think JLCPCB. Easy, affordable, and reliable. After many grueling hours of rubbing my single brain cell against this piece of paper, I have formulated a plan. It's not a very complicated plan, but let me walk you through it anyway. I'm going to take two non-contact temperature sensors, one long range and one short range, and connect them to an ESP32. I'm also going to use a TFT display and some buttons to control and see the temperature sensors. I'm going to power it off of a battery because this ESP32 has a built-in battery charger, so it would be silly for me not to use it. And after I've confirmed that all of these components work the way they're supposed to, or at least the way I hope they do in my head, I'm going to 3D print an enclosure to put all of them into. It's not a requirement that it looks like the previous temperature sensor, but it is a convenient shape that I'm hoping to replicate. Coincidentally, I have all of the components I need for this project. They're all from dfrobot, and they were supposed to be for a different project, but I'll tell my Patreon supporters about it. So I have the two temperature sensors right here. This one's long range and this one's short range, and I have a full-length video about how they operate and how you can use them. I have a TFT display which comes with an SD card slot. I'm not sure what I can use that for, but maybe I can save readings onto it. I'm not sure. And I have an ESP32 C6 firebeetle, again from dfrobot, and it has a very convenient plug for the actual screen. So that's nice. So I'm going to connect all of these components together and upload some code to see if it actually does the thing I need it to do, and then I'm going to solder up some buttons so that I can control what it's doing with that. But first, let's get some readings appearing on that screen. I apologize for the outfit change. I had to run a very quick 6K, but now I'm back and everything is connected. So I've got the screen working, I've got the temperature sensors working. I did have to connect them individually and change one of their I2C addresses because they're both on the same I2C line, but everything works now. And as you can see, we've got the area temperature and the object temperature per each sensor. So each sensor tells you the temperature of the object that it's looking at, and also the temperature around the actual sensor, so it knows how to offset and things like that. And now theoretically, if I just stick this into my ear, we should get 36.0, 35, Okay, that looks a little bit low. Annoyingly, I don't actually have anything to compare it against anymore. So I think for the actual thing, I'm probably just gonna have it check for like 5 seconds and like average out. I would not use this for actual medical emergencies because it's probably not a medical grade sensor, but I think for what I'm doing, it will work fine. I'll probably just be walking around the room and checking the temperature of things when it gets warm or cold, whatever. So I guess the next thing is to actually, what is the next step? I guess I need to check if it works on battery, so let's plug the battery in and, wow, that's underwhelming. It just works. Okay, cool. So the battery problem is solved. I need a 3D printed case and buttons. I need buttons, that's what I need. Okay, so I'm gonna make a little board with some buttons on it so that I can press things and it will do things for me. Cool, buttons. It's currently Sunday. I try really hard not to work on the weekends, but when you're a self-employed YouTuber, time is a flat circle. Also, I'm stressing out because I need to fly out to open source on Friday, and I really want this project to be done by then, along with the thumbnail video and everything. So, anywho, the keypad is done. I didn't record any of the process of me making it because I was stressed. But anywho, it's running off of the battery right now, so if I hold down the middle button, it turns on. And now I have the top button and the bottom button set up to control each of the temperature sensors. So if I hold down the top button, it gives me live readings from the long range temperature sensor. And I can also press it so that it gives me just one reading at a time, and exactly the same for the bottom button for the other sensor. That is perfect. And if I hold down the off button again, it should go back to sleep. Perfect. I don't know how long it's actually going to last in deep sleep mode, but hopefully long enough for me not to be too bothered by it. But yeah, now that all of this works, I need to set it up with something, well, normally I would show you how I would use this with something like Home Assistant, but I'm not actually using Home Assistant for most of my health tracking stuff. Like even the toothbrush, after the video, I switched it over to my personal health tracking app, which is in very deep development. So I'll only show you little bits of it. But yeah, that's what this is going to communicate to. Not to Home Assistant, but to my personal tracking app. So I'm gonna do some code, incorporate it into my tracker, and then show you that. And then we can start working on a case. So yeah, let's do that. I've been playing around with this for a little bit and I've got the code to work. So currently, if I turn it on, it will turn itself on, connect to Wi-Fi, and I can select the user. So I can select myself, and then I can put this in my ear and click scan, and it will measure for a couple of seconds and then actually give me a reading. The problem is the reading is always low. Like I'm fairly confident that my temperature right now is not 35.3 degrees. I'm not sure what I can do about that. Like, I'm not expecting these to be like medical grade temperature sensors, but like I went over it with Claude as well by giving it like the data sheet and everything and trying to make them more accurate, and all it really suggested is just taking readings for longer and averaging them out, which doesn't really solve the problem. Now, I'm somewhat convinced that it's only off by like 1 degree, so I could just like put it up by a degree, but like it's not, it's fine if I'm like, you know, if I deselect a person, I can still get live readings. I'm fairly confident that this is accurate enough for when I want to like check the temperature of the radiators or something like that. But yeah, for my actual in-ear temperature, it's a little low, and I'm not sure what to do about that. I'm pretty sure I can do something in code, even if it's just like adding an extra degree. Also, yes, I am getting the readings in my actual app, so they do pop up, so that's nice. Yeah, it's just a little annoying. I just thought they'd be a little more accurate. I mean, I guess 1 degree isn't that bad, but it's whether I just want to add the 1 degree as an offset kind of thing, and then if it's wrong, you know, it's not that big of a problem. I really wish I had a temperature sensor that I could compare against, and then I could actually like average out the offset instead of just guessing. But yeah, that's where I'm at. I'm gonna take the rest of today off because it's 5:30, and working past 5:30 on the weekend is not how I like to do things. So tomorrow I'm gonna start designing a case to put this all in, because at the very least it's still just a good thermometer thing that I can walk around with and check the temperature of things, right? So let's start. Well, I'm going to take a break and then come back and then come back to design the enclosure tomorrow. So see you tomorrow. So after I finished recording yesterday, and I kept playing with the sensors and everything to see if I can do anything about the accuracy, and I couldn't. So by the time I woke up today and got into Fusion to like design an enclosure for all this, my morale was pretty low, which led me to designing a case for this that is the bare minimum viable case. Here it is. When I design a minimum viable case, the idea of fasteners doesn't exist, cable management is kept to a minimum, and it's basically going to be held together with hot glue. So it's time to assemble it. Well, here it is. I don't know if my standards have just lowered or this actually looks pretty good for a prototype. Oh, I forgot to do the peel. One moment. That was a somewhat unsatisfying sound. Anywho, it works pretty much exactly as I intended, apart from the whole accuracy thing. But if I hold down the on button, it takes a couple seconds and it will turn on. Like so, and then with these two buttons I can switch between users. So I've got one user and then second user, and then I've got just regular view mode right there. So if I want to view temperatures, I can do that. So I've got long range on the top, so that will tell you the temperature from this sensor up here, like that. And I've got the wide range on the bottom from this sensor here. I will say the sensor positioning isn't perfect. I do find holding it like this is pretty good, but then when I need to use the wide sensor, I need to kind of hold it out like that. It's kind of awkward. I probably should have put them both up here, but then I didn't like the fact that one of them was longer than the other, and it was asymmetrical, and I just didn't like it. So yeah, if you hold it down, you get live readings like there, and if you switch onto a actual user like Mellow over here, I can then press the read button, and it will like actually take a reading over a few seconds, and then it will tell you what that reading is. Send failed. Oh, Wi-Fi connected. Interesting. Maybe it's because Jamie isn't set up as a proper user yet, so that might be my bad. Okay, so if I now stick this into my ear and scan my temp. Oh, I've just realized that the other temperature sensor actually has like a little beep to tell me when it's done. This one does not. 35.2, and it's sent like that. That does seem a little bit low for a human temperature, so I will disregard these readings. But for the most part, it's pretty cool. I can walk around and check the temperature of... Oh, okay, I need a cancel button because I've went into measuring mode again and it wouldn't stop. Okay, so I need to exit the person view, and now I can actually check live temperature of things. And yeah, walking around like this, it's pretty cool. I can kind of see the wide area of temperature, and then if I need to like narrow in or something, like my Wi-Fi router, I can tell you that it's currently running at 35 degrees, which I think is normal for this router. I wouldn't know. Anywho, it does work pretty well. It's not exactly what I needed it to be. Also, the battery's probably not going to last very long because the screen, even when it's off, and you turn it off by just holding that button,
even when it's off, the screen and the two sensors still consume power. They still have 3.3 volts running through them. I think it's going to be fine. It's probably not going to last very long, but then I don't see myself using this for, again, nothing medical related. I did buy myself a new sensor, a new temperature sensor. I figured this wasn't going to work, so I did order myself a new one. And also, I didn't actually pay the retail price for the original sensor that I broke. I got it secondhand. And same with the new sensor that I just ordered. I very rarely buy things new unless I know I'm definitely going to be using them. So yeah, here's how to make a little temperature sensor that you might like to walk around the house with, or something like that. Anywho, thank you very much for watching. Next week I'll probably have a video about open source, so that would be pretty cool. Don't forget to like, don't forget to subscribe, support me on Patreon if you can, and share the video. That's a new one. Share the video with someone you might like, or you don't like, or you share the video. Goodbye.
Also, I did not intend to coordinate my filament with my outfit.